Okay, beautiful people, here is the video that I promised you. We're going to integrate with the trig functions. So you really need to have, before you look at this, you need to look at the stuff that's on BCPS1 to make sure that you have all of your note cards done and you've looked at the examples. The examples that I'm going to do here might be different than the ones on BCPS1, but too many examples is never a bad thing. So I'm going to start by saying if you have a problem like this, all right, and you see that the integrand is nothing but one trig function, you want to have your note cards out, because if this integrand is just a cosine, we have a note card for that. There's a rule for that. And so if the integrand is exactly like one of those rules, your u substitution is for the angle. So we're going to do the same thing that we did before. We're going to let u be 3x. Same idea as before. The integral of cosine u. So now it's looking more like the rule. Here's u. But I still have the dx. So remember, the major faux pas in integrating is a mismatch of these variables. Remember, this dx is not there to be pretty. It's there as part of the integrand and necessary. So we're going to take the derivative of our u. So du dx is 3. And so du over 3 is dx, and you can sub that in. So we're going to get the integral of the cosine of u times du over 3. Pull the 1/3 out, and now that is exactly a rule. So look at your note card. What's the integral of cosine u du? That's sine of u. So we get 1/3 sine of our angle, 3x, and then plus our constant. Okay, that constant is still there because it's an antiderivative and we're looking for the family of curves. And so when I take the derivative of this, the derivative of any constant is 0 and it goes away. So now if you're thinking, can I use the finagling factor on that? Like, can I say, hey, the derivative of 3x is 3. I need the 3, so I need a 1/3 on the outside. Absolutely. That is still appropriate in this problem. All right, let me see if I can get a new slide. All right, so now let's just do another one. If I do the integral of secant squared of 5x squared dx, but I have an x on the outside. All right, so remember what I told you. There's no such animal as a product rule. Well, there sort of is, but not before the AP. So integration by parts is sort of a product rule, but we are not dealing with that right now. So that x on the outside is just in my way. I'm looking at the trig function, and I see it's secant squared. And I'm looking at all my note cards, and I have a rule for secant squared. So I'm going to try to let, if I have the rule there, I'm going to try to let the u substitution just be for the angle and see what happens. So u is 5x squared. The derivative of that is 10x. And so du over 10x is equal to dx. So I'm going to leave this x alone. Here's x. I get secant squared of u times du over 10x. And now this x and this x, they cancel out, which is what we want to happen, because now that extra little piece is gone. Why? Because he's needed as part of the derivative of this angle. So I'm going to pull out the 1/10, and I get the integral of secant squared u du. That's a rule, exactly a rule. So I know that that's equal to 1/10 times, whose derivative is secant squared? It's tangent. So I get the tangent of our angle plus c. Done. All right, so you got to have your note cards out and you got to look. So now, when you get something that looks like this, let's say I have cosine cubed 3x sine 3x dx. All right? And you're going, okay, oh crap. Like, that's not a rule. Like, you don't have a rule that says cosine cubed times sine. You don't have a rule that says that, right? There's no such thing. So I'm going to go back and try my other way. All right, look, I do have a quantity raised to a power, right? If I rewrite him, this cosine of 3x, he's cubed. And then I have him on the outside. So, hey, I'm going to try my u to the n du. See if that works. I got to try something. And all the problems that you have right now can either be done by these new rules or by something that you already know. So I'm going to try something that I already know. I'm going to let u be the cosine. Why? Because he's raised to a power, and that's all I know how to do at this point. Well, I'm just going to try it. So I get u cubed, but I still have all of this left, and so I'm not going to fret until after I take the derivative and he doesn't go away. So what's the derivative of cosine? It's negative sine of our angle times the derivative of our angle. So du over negative sine 3x times 3 is our dx, and that's going to go in. So look at what happens. We get u cubed times the sine of 3x dx. Oops, I don't want to put that in. I want du over negative 3 sine 3x. What happens? Looky, looky, looky. Yippee-yi-yay, there he goes. And let me get a new slide. So now I get negative 1/3 integral u cubed du. So now we're ready to integrate. This is an old one. I get negative 1/3 times u to the 1 higher over that 1 higher plus our c, and then we sub back in. So I get negative, oops, I don't want that, negative, oops, negative equals negative 1/12 times our cosine of 3x to the 4th power plus c. So what's the key? You look at the integrand, you see if it's a rule. If it's a rule, great. The u substitution is for the angle. If it's not, then try u to the n du. Okay? Those are all you have. And if that doesn't work, oh no, you might have to try an identity. That could happen, but we'll talk about that more in class. All right? So that should be good enough to get you through mandatory 3. Remember, you can email me. Don't go through BCPS 1 though. It's easier just to go dweber at bcps.org. Enjoy your snow. Bye, guys.